Hello and welcome to LAN Architectures for VoIP Delivery over Broadband. There's more than one way to skin that LAN. I'm Jim Mormon and I'm going to be talking to you today about the different LAN architectures you can use when deploying voice over IP over a broadband connection. What we'll be discussing is how calls are delivered across the public internet, the types of LAN architectures that can be deployed to ensure higher quality delivery, some common problems and issues that you might run into, and how we can guarantee quality of service. So here you'll see that this is a typical office LAN, and if you're a managed service provider, this is something that's very simple for you to understand. You've got the PBX and the data network completely separated. PBX goes out to the public switch telephone network, whereas the data goes out to the public internet. The data side has a data switch and a router, whereas the PBX is a standalone device. Both the data and the PBX feed individuals or workstations at the office. What we're going to be talking about is when you move the PBX to a data environment and take it off of the public switch telephone network, you have an IP PBX that actually replaces the traditional PBX. You introduce an edge device right over here, and the voice traverses the LAN as data packets versus the digital or analog signal that it would over the public switch telephone network. There's no guarantee of latency or throughput when you put calls over the public internet. The peering points aren't guaranteed, and there really isn't a point of escalation. So it's best to implement good LAN practices when deploying voice over the public internet. So how calls are actually delivered across the public internet is something that you may want to understand. SIP is something that is an acronym that you hear quite often. SIP trunks, it handles SIP delivery. SIP is actually the protocol that establishes the connection between the PBX and the soft switch or the service provider. It's not the stream of voice that goes back and forth from you to the other party on the other end. RTP handles that. SIP is just handling the connection. As you can see, an RTP packet is a data packet that's just like an IP packet. There can be typically two different codecs, G711 or G729. G711 is what I would call almost uncompressed voice quality. It's the highest quality voice that you can deliver, whereas G729 is a compressed voice codec that makes the call sound what I would consider to be cell phone quality. The voice packets are broken up into chunks and sent over UDP. An edge device is used to control bandwidth utilization. It's a point of demarcation of responsibility. It's a good location for troubleshooting, and it allows us to have a place to give network support to the phones. We always recommend putting the edge device first, unless you have a customer who is going to insist that their firewall reside at the edge. In that case, you're going to need to be able to work with them to get their device to serve the proper rate shaping role and give you a view into the network performance. Or they can take responsibility themselves for ensuring quality of service and SIP termination. The edge device we use is from Edgewater Networks. It's called an EdgeMark, and we've standardized on the 4550 series. The edge device theory is that we can either use it as a session border controller to bypass the firewall, or we can use it on the edge to do traffic shaping so that the voice gets priority over the data, and the data gets kind of smushed down to the bottom when a call's in progress, and then when the phone hangs up, the whole pipe is able to be used for data again. This is our best practices. Should you put an edge device in on your own, we recommend transparent proxy mode, change the SSH password, and set up SNMP so you can monitor what's actually happening. Now the LAN design theories are three basic models that we'll talk about today. VLANs, we can split the network, or we can run a flat network. VLAN is the most recommended and reliable way to deliver voice over broadband. And a virtual LAN is exactly that. You separate out via IP on the LAN with VLAN capable switching, a separate network for the voice than what you would with the data. It's a little bit higher complexity, but not too much. Your switch still could potentially get overloaded, but VLAN is the recommended way to architect a LAN when you're delivering voice over broadband. Sometimes we'll see people do a completely physically split network where they run two Ethernet jacks or two Ethernet runs to every single desk. This typically isn't practical, and I'll see it usually when there's a new office construction build out and they really want to separate the LAN for one reason or another. One of the times I've seen this actually happen was when there was a client who was moving to a new location and they wanted to utilize some existing hardware, and it was just a simple managed switch and on the data side and some servers and routers and whatnot, and they wanted to put a PoE switch in for the voice over IP installation. So they ran two Ethernet jacks and they physically split out the networks, and that way they could put a UPS battery backup on the PoE switch on the separate network, so that in the event of a power outage, the PoE switch would be backed up on battery, whereas the traditional managed switch for the data side would just go down. They didn't want to spend the money to completely replace out the PoE switches from the get-go, so they wanted to step into it, and this was the way that they did it. But this isn't a very common thing because of the increased cabling costs to run two Ethernet jacks to every single desk. And then we have the flat network. We typically recommend this for smaller installations where you don't run a VLAN. You just definitely want to use the QoS device, the Edgemark in this installation, for the bandwidth prioritization, and it just is a single switch with the phone and the cable. The way that the phones work is typically you'll see a computer plugs into the phone plugs into the Ethernet jack, so you only need one jack at the actual desk. And then everything routes back to a switch, whether it's PoE or traditional managed switch. And as I just said, power over Ethernet, what it does is it passes electrical power along with the data on the Ethernet cabling. So the single cable is providing the data and the electrical power to all the devices on that LAN. It's great for offices where power fluctuations can occur. Obviously it reduces clutter at the workstation. It's a little more expensive than standard managed switches, but we recommend it because the power cord, the actual AC power cord for the phones, can increase the cost per seat, $15, $20 per person just by adding AC power, whereas a PoE switch may cover that cost when you look at it aggregately throughout the entire office. And PoE is certainly not mandatory when you're deploying a VoIP installation, but it is recommended. Some common problems we hear about are packet loss, jitter, and delay. Packet loss is typically due to hardware congestion. Jitter is a difference in delay between those RTP packets. So it's when the RTP packet, the voice stream, actually arrives out of order. And then delay is slow links or long distances. These are the three most common causes of network-induced quality problems that your smart LAN design can solve. There's other issues that can reside at the service provider level, but ensuring the LAN is an issue can really reduce the time service is impacted during troubleshooting and support. Common problems and issues we also run into are when your client has a internet connection from a broadband provider like Comcast or Time Warner or any number of people. Typically they will promise big bandwidth, and it's up to us to make sure that the bandwidth that the client actually receives is what they're supposed to be receiving, or understand what it is they actually receive so that we can size the installation accordingly. We recommend 100K per call, both upload and download. And broadband connections are going to provide you with greater download speed than they will in upload speed. So you get 5 megs down and let's say 1 meg up. And if you're looking at a 1 meg upstream and you want to support 10 concurrent calls, that's going to be the entire 1 meg. So we're probably not going to recommend that we look at doing 10 concurrent calls on a 1 meg because the client's likely going to be using the internet for other applications as well. And voice adds a little bit of overhead, so we might look at doing 50% of that. So say 5 concurrent calls or 6 concurrent calls on a 1 meg upload, and then recommending to the MSP or the agent that you guys do speed tests to ensure that you're actually getting that 1 meg, or what is the actual speed that the client's realizing on the upload. Typically we see firewall issues, and that's why we put in the edge device to bypass that firewall, because we can run into problems with that. Once in a while I see bad CPE or cabling or hidden hardware, or you could have a saturated network where the central office that services your client is oversubscribed, and they might be realizing their 1 meg upload speed at 10 a.m., but then at lunch when everybody else gets online it goes down, and they're having call quality issues around lunch and common times when people will jump online and start using the internet. So we want to ensure that the internet access is up and functioning properly, that the local equipment is actually turned on and functioning, that it's hooked up correctly, that the cabling and physical network are certified, and that, like I said, we've double checked the network speed to make sure we're actually getting the speed that the bandwidth provider is promising. When you're delivering a voice over IP call on the public internet, there's no way to actually guarantee the quality of service. We put in the edge device, we prioritize the bandwidth, and we make sure that the best practices are in place so that the client is likely to get a really good experience on their call quality. But for a client that needs a guarantee, they actually want that 100% with the SLA, there's only really one surefire way to guarantee quality of service for VoIP. And that's to run a dedicated point-to-point circuit, whether it's a T1 or a Metro Ethernet circuit or T3, from the voice service provider to the end user. So in the case of NSUNet, we would run a dedicated circuit from the NSUNet soft switch all the way out to the client's location. And they would be the only one using it. They would have SLA with the circuit, and if we control the router at both sides, that means we really can guarantee that quality of service for that client. So this is what I was talking about. It's DIA, and this is just a really fancy diagram for a string between 2 tin cans, and the tin cans are NSUNet and the customer. Whether it's a T1, a T3, or a Metro Ethernet connection, it's a dedicated point-to-point circuit from us to them. On-net just means that the client has internet connection from either XO or Level 3, who are our upstream providers. And if they have a direct internet connection, even if it's just going out to the internet from that client location and it's not directly connected to NSUNet, it's going to take less hops and traverse less points on the internet to get to us. And so that's considered what's called an on-net connection, and that's good. The less the call has to travel, the better the quality is going to be, and the less likely we are to encounter problems. And with that, I will conclude and say that if you have any questions, please contact me at jimm@nsunet.net or call me at 216-619-2000. I'm at extension 100. Thank you very much. Hope you found the information valuable. And there's my email address right there should you have any questions or concerns.